This is the prep packet video for Unit 4, Chapter 9.7 for Objective Number 1, where we work to understand the steps for solving a radical equation. So before we start, let's make sure we understand what a radical equation means. So a radical equation is an equation that has a radical in it. It's that simple. And of course, it's an equation because there's an equal sign involved. So that's nothing new for you. You guys understand that. Basically, what you're going to do if you have an equation that has a square root, we square both sides. So if I'm starting out with that and that, I just square both sides. The most important thing to think about with this is that you're going to end up with something called an extraneous solution from time to time. And the word extraneous means basically extra. You don't want it. No. An extraneous solution, it's an answer, but it doesn't actually work for the original equation. So we need to check that for every single problem that we do. Here's a procedure list. Just like with many things, if you were working with a variable to solve for x, let's say, you would work to get x by itself. Well, by the same idea, you're going to get the radical by itself. And we'll come back and look at this when we actually have some more to work on. So let's, for example, take this equation, and we're looking at the square root of c minus 2 equals 3. So here's my radical. And I need to solve for the variable which is c. And right now, that's going to be kind of hard to do. So I'm going to square both sides, because what I do to one side, I can do to the other. Remember, if I am squaring, here's my secret too, right? If I can make a rainbow, c minus 2 comes out. And here, 3 squared is 9. And all of a sudden, you're in familiar territory. You know what to do to solve for c. I'm going to add 2 to both sides. And c will equal 11. But we're not done. Let's make sure that this actually works. So I'm going to go back to my original equation, and I'm going to plug in 11 for c. Do what's under the radical if you can. So 11 minus 2 is 9. And indeed, the square root of 9 is 3, and 3 does equal 3. So you've checked it. That's something I want to see, that you have done that. So let's take a quick look at back here. We got the radical by itself. That was already set up that way. We squared both sides of the equation to eliminate the radical. So we did this and this. We combined like terms on each side of the equation. So we got all the variables on one side and all the numbers on the other. And in this case, we were done at that point, so there weren't any more radicals. And we solved the equation, and then we checked the proposed solution in the original equation. And we were lucky we didn't have to throw anything out. Let's take a look at another one. Here I have the square root of t plus 5 plus 6 equals 0. And I have to work to get this by itself. That's my first step. So to do that, I'm going to subtract 6 from both sides. Be very, very careful to leave what's under the radical sign intact. Don't try to split that up. You just want to get those constants out of the way for now. So now I have the square root of t plus 5 equals negative 6. Now, I'm going to square both sides to cancel out the radical. Right? What I do to one side, I do to the other. We end up with just t plus 5 on this side And negative 6 squared is 36. So now I'm just going to solve for t. And t equals 31. Let's double check it. Is it true that the square root of 31 plus 5, and make sure that goes all the way over, plus 5, so, whoops, plus 6 equals 0. So do what's under the radical first. The square root of 36 plus 6 equals 0. The square root of 36 is 6. Whoops. Lots of whoopses today, huh? The square root of 36 is 6 plus 6 equals 0. So that's not true, is it? So this would be an extraneous solution. Now, if you were going back and you did think about the square root of 36 could be plus or minus 6. If it were negative 6, it would be true. But for now, let's just, right now, both solutions won't work, so it can't work at all. Let's try another one. This is more simple. Here we're just going to, we don't have to add or subtract, we just have to square both sides. So I'm going to square that, and I'm going to square that, and I'm going to have x equals 49. And we'll check it. Is it true that the square root of 49 equals 7? Yes, it is. Let's try another one. That was pretty fast. Let's go and look at this one. So here, now we have an expression as a radicand. So let's double check it. Let's see what happens. The square root of b minus 8, if I square that, does it equal 2 squared? So b minus 8 equals 4, plus 8 on both sides to isolate the variable. B equals 12. And now let's check it. Is it true that 12 minus 8 square rooted equals 2? The square root of 4 equals 2. 2 equals 2. So there were no extraneous solutions, so you're good with that. One more. Okay, so we have a little cleaning up to do here. So I'm going to subtract 7 from both sides, and I'll have the square root of w plus 3 equals negative 4. If I square both sides, I have w plus 3 equals 16. Now let's test it. The square root of 13 minus 3, plus 3, sorry, plus 7 equals 3. The square root of 16 plus 7 equals 3. Four plus 7 equals 3. If it were plus or minus 4, that would be true, but in this case with the principal root, it's not. I'm sorry, I had to interrupt for a moment and come back. We talked about that this would work if it were negative 3, but what I want you to think about is it has to work for both the positive and the negative value for it to be true. So in this case, by using 13, it wasn't true because it wasn't true for both of them. So for one last little bit of practice, I want you to do the U-tries on page 580. And make sure you include that work with your prep packet. And we'll see you in the next video.